Hello 4%, this is Anton, and today we're going to be discussing yet another somewhat mysterious signal that was detected just a few years ago and still does not actually have a very good explanation. Or basically here we're discussing another persistent astronomical mystery that seems to be in our own backyard, in the Milky Way galaxy. Although in this case this is not a radio signal, but instead represents something that produces a huge amounts of energy and is actually a very strange source of some of the most powerful radiation ever detected. Here this is a mystery of the object referred to as LHAASO J2108+5157. And it's named LHAASO because of the observatory where this was discovered. The Large High-Altitude Air Shower Observatory located in the mountains of China. And while here this observatory is really good at detecting certain types of cosmic showers, or basically events involving very powerful particles or extremely powerful radiation that then interacts with the upper atmosphere of planet Earth and produces a cascade of different subatomic particles detectable on the surface. And back in 2021, this observatory released a list of what's known as Pevatrons. In this case, a Pevatron is a new term that represents some kind of a source of extremely powerful radiation and usually involves some kind of an astrophysical accelerator inside the Milky Way galaxy. It's called Pevatron because it's able to produce peta-electron-volt energies, or basically some of the highest possible energy observable in our galaxy. And this usually involves a lot of gamma ray emissions and very powerful cosmic rays. But normally these are basically just supernova remnants or binary systems involving black holes and sometimes very powerful pulsars. In other words, for the most part in the last few years, most of these sources have been identified as some kind of an individual object, very often involving black holes or neutron stars. For example, here's one of them that was actually analyzed by NASA a few years ago, and this turned out to be a pulsar. And so many of these astrophysical accelerators usually push a lot of particles to extreme energies that can then collide with different types of gas as they travel across the galaxy and basically produce ultra high energy gamma rays detectable on our own planet. They sort of resemble this. And so in some cases these actually have been used as a smoking gun to discover some kind of a supernova remnant, which usually contains a pulsar or a black hole, but also contains quite a lot of gas around it, which is usually what then produces these gamma rays. But out of all sources we've discovered so far, there was one that really stood out. Mostly because it was basically completely dark in all other frequencies. Or in other words, even though a lot of other Pevatrons also produce radio emissions and produce X-rays, and sometimes even produce other wavelengths, mostly because the source of the energy is able to generate additional frequencies. Strangely enough, this object, LHAASO J2108+5157, seemed to be completely dark in other wavelengths. It was really only producing gamma rays. In this case, researchers could not explain what's actually producing it. A pulsar or a black hole would definitely produce other frequencies. And so trying to figure out exactly what this is, and also trying to figure out how many of these other Pevatrons are formed, would actually solve a lot of mysteries in regards to cosmic rays, and especially in helping us understand how our galaxy is able to produce these extremely powerful particles. In many cases, there are still quite a few mysteries in regards to the origin of the cosmic rays. You can learn about this in some of the previous videos in the description. And so for several years, researchers had several explanations. The first obvious one was some kind of a hidden supernova remnant. And this was actually reported in a study back in 2023, because in this case, this source was located very close to massive clouds of molecular gas. And so here the explanation was that the protons, or the remnants of hydrogen, seemed to be accelerated to incredible speeds and then collided with the gas nearby, crashing into these clouds and producing gamma rays. But for this to work, there had to be a powerful accelerator nearby, so basically some kind of a supernova remnant. However, following the initial search, no such remnant was discovered, with the researchers using computer simulations eventually concluding that if the supernova remnant is here, first of all it has to be extremely young, less than 10,000 years old, but second of all it has to be very close to these clouds, within approximately 200 light years. But the thing is, they didn't find anything like this, with the only conclusion from the study at that time suggesting that it was maybe hidden by the clouds, or essentially suggesting that if there was a supernova remnant, it was maybe hidden by massive amounts of molecular clouds and might be just too faint for the current radio telescopes to see. And so that was the overall conclusion from this study. But following years of discovering pretty much nothing, this new study from 2026 tried to analyze this region using additional wavelengths, and especially using the infrared observations, because maybe, if there is some kind of a pulsar here, it might illuminate the gas in just the right way to make it heat up and produce infrared emissions. And so this recent follow-up study by Josep Martí and his team in Spain used the observations from the Calor Alto Observatory to look at this region in the infrared light, with the only hope basically being discovering the hidden source and discovering this bizarre hidden object. And specifically they were looking for two things. If this was a supernova, it would actually produce a lot of shocked gas, as the emissions from the supernova would be creating dramatic interactions with the cloud around it, which would be producing certain infrared observations. Or maybe this contains some kind of a microquasar, or basically a black hole or a neutron star that contains some kind of a partner that it's stealing a lot of mass from, that's then basically producing these powerful emissions. And if so, this should also produce certain observations in the infrared and should resemble other microquasars that we've seen before. But following this very thorough analysis, turns out, well, there was no breakthrough and no new discoveries. The team so far found no evidence of anything and no object whatsoever. There's no shock gas, there are no unusual nebular structures, and there is no microquasar. And even though previous studies suggested that there might be some kind of a microquasar candidate nearby, this was based on a radio study from 2025. In this study, the infrared analysis suggests that the candidate's properties are completely incompatible with either a galactic microquasar or even some kind of a nearby radio galaxy. Or just to rephrase this, the gamma ray source does not seem to match the location of the radio source that was previously used to explain these emissions. And so they don't seem to be in the same location and don't seem to match at all. Moreover, when they actually looked at this microquasar candidate a little bit more, they did actually discover something here, suggesting that the radio source was not even in our galaxy. It was actually probably some kind of a distant galaxy, billions of light years away from us, and very likely had nothing to do with the gamma rays we're observing. Or basically implying that none of the other sources discovered in other studies seem to match the observations from this gamma ray source. And so I guess the question is, so what's the conclusion, and where does this leave us? Well, the only thing that we know for sure is that this seems to be inside the gas clouds, suggesting that the source seems to be interacting with these gas clouds to produce gamma rays. So basically suggesting that the actual mechanism still has to involve a lot of these very energetic protons or cosmic rays striking the gas. Moreover, the study also concludes that this is not just some kind of a background gamma ray radiation, as the cosmic rays in our galaxy are not strong enough to produce so much light, meaning that there must be some kind of a source after all, and this has to be some kind of a physical object. This has to be a specific accelerator. But despite all of this, and despite additional observations in the X-rays, radio light, and infrared light, nobody still has any idea what exactly this is. No actual counterpart has been discovered in other wavelengths, and this object remains just as mysterious as it was back in 2021. And so for a lot of astronomers studying gamma rays and cosmic rays, this is right now one of the biggest persistent mysteries. This is one of the few known gamma ray sources in a galaxy that seems to have absolutely no explanation. It's basically some kind of a dark emitter whose true identity is still unknown and that has no explanation whatsoever. But even though this particular study doesn't actually find anything, in science this is still important because by not finding something, we're essentially ruling out various possibilities and various other explanations, which will eventually provide us with an actual answer. And so now by ruling out that this is a microquasar, or that it contains some kind of a visible supernova remnant, we're slowly getting closer to the answer of what exactly this source is. And actually, for all we know, this could be something entirely different and something we've never seen before, which is why right now, no actual explanation seems to make sense. Luckily though, we do have additional telescopes that are going to be operational pretty soon that may provide more answers. As a matter of fact, the Cherenkov telescope array that's going to become operational pretty soon will have a much better resolution to potentially see some of the hidden structures inside of this object and to help us figure out what it actually is. But until these future discoveries, or until someone actually solves this mystery, this is a pretty good reminder that even today there are still so many unanswered questions in astronomy, and even right here in the Milky Way galaxy, we seem to have certain sources that seem to involve these extremely powerful engines that we just don't understand. At the moment, there is really no explanation for what's causing these super powerful gamma rays. But there are other mysteries we discussed recently, and you can learn more about them in some of the videos in the description. Anyway, once we have some updates, we'll come back and discuss this more. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access. You can also support this channel by buying a Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.